Question 3, we have a particle projected with speed 10 at an angle tan inverse 3/4 to the inclined plane. Here's my inclined plane. And we know we have the inverse tan. We need to get the cos and the sine. So here's my angle A. Opposite over adjacent, hypotenuse is 5. Cos A, 4/5. And sine A, 3/5. So my initial vector, 10. U cos A, 10. Cos A in the I direction plus 10 sine A in the J direction is going to give me 8i plus 6j for my initial vector. If you want to call it U1, you can. So our accelerations will be based on this triangle down here. So we have inverse tan of 5/12. 5/12, hypotenuse 13. So cos B, 12/13. Sine B is 5/13. My accelerations are in the I direction. Acceleration in the I direction is going to be minus g sine B, and in the J direction minus g cos B. So minus g sine B is minus 5g/13, and minus g cos B is minus 12g/13. So these are my accelerations. So we're asked to find the range, so we need to let s of y equal 0. So ut plus a half at squared is equal to 0. So we have 6 for my initial in the j direction or the y direction. So 6t minus the acceleration is 12g/13. So minus a half times 12g/13 times t squared equals 0. So we're going to get 6t minus 6gt squared over 13 is equal to 0. So factor out your t to get 6 minus 6gt/13 equals 0. So we have my initial time is equal to 0, or 13 times 6 divided by 6. Well, 13 times 6 divided by 6 is going to be 13. So we're going to get 13, and we'd have to divide by g to get t. So 13/g is equal to t. Now we need to plug this into s of x. So let's find out s of x. We're going to have same equation, ut plus a half at squared. So we have the 8 for my initial times the time, which is 13/g, plus a half times the acceleration, which in the I direction is this minus 5g/13 times t squared, which is going to be 169/g squared. So this is s of x. So we're going to get 8/13 is 80 and 24, 104/g minus 13 will divide into 169 13 times. The g will cancel with one of the g's on the bottom. So we are left with minus 5 times 13, which is 65/2g. So this, if I multiply top and bottom here by 2 to get 2g in the bottom, I'll have 208/2g minus 65/2g, which is 143/2g, which is my range. And then we were asked, show that after 2/5 of the time of flight, the distance along the line of the inclined plane through which the particle has traveled is 28/55 as a fraction of the range. So 2/5 of the time of flight. So let's get 2/5 of the time of flight. So 2/5 of 13/g is going to be 26/5g, which is my new time. So we need to see how far it's traveled in this time. So s of x in this time is going to be 8 times 26 over 5g plus a half times a, which is not changing, minus 5g over 13 times t squared, which is 26 squared over 25g squared. So what does this become? 8 times 26 is 160 and 48, 208 over 5g, and then it's going to be minus 2 by 13 is 26, which will cancel with the square. So we're left with 5 26s, 130 on top, and on the bottom we're left with, I can cancel the g with one of the g's, we're left with 25g. So if I multiply top and bottom by 5 here, I'm going to get 1040 over 25g minus 130 over 25g, which is going to be equal to 910 over 25g. You can type this into a calculator. You can divide by 5 to get 182 over 5g. This works out to be 36.4, if I'm right, 36.4g. Okay, so we need to see, is that the fraction they were giving us was a 28 over 55? The fraction of the range 28 over 55 of the full range. So here's my range, 143 over 2g. Multiply that by 28 over 55. And you get that into the calculator, you will get, did I put the g on top here, down the bottom? No, it should be over g. Let's tidy that up. 36.4, and this one, if you type it into a calculator, we'll get 30.6. Turn your phone off when you're working, and these are equal, so QED.